All right, our next section on our factoring is going to be factoring by grouping. And factoring by grouping is kind of what I would call a bridge method. You aren't going to use the actual grouping problems we're going to do today a whole lot, but it makes some more advanced problems a whole lot easier that we're going to do tomorrow. So this factoring by grouping is going to be a helpful tool, even though the exact problems we're doing today might not be the ones that we use in application. But when we talk about factoring by grouping, we're going to use that when we have 4 terms in a polynomial. And what we're going to do is we're going to split those 2 terms into 2 groups, and we're going to use our GCF factoring, and we're going to do that twice in the same problem. Let's look at an example of what that looks like. So our first example here, you see we have 4 terms in our polynomial. That tells me I want to use factoring by grouping. There is no common factor to all 4 terms. I can't divide anything out of all 4. But factoring by grouping means we're going to split this problem into 2 separate problems. We're going to factor something out of the first pair and factor something out of the second pair. So, in the first, I have 4x cubed minus 12x squared. I factor out a 4x squared. That is the greatest common factor, which leaves x minus 3. Out of the second pair, I now look at 5x minus 15. I can divide 5 out of both of those. And then when you look at this, hopefully you're recognizing that our parentheses end up being the same. This will always happen when you are doing factoring by grouping. Those 2 parentheses will always end up the same. That's a really important idea. Now, these problems today are just going to magically happen that way, but when we use this for more advanced factoring, there's a reason why those parentheses will always end up being the same. And so this x minus 3 is in both terms. If you notice, we now have a problem that has 1 term plus a second term. Just like we did above here, we divided 4x squared out of both terms. Out of these 2 terms, they both have an x minus 3. So I'm going to divide x minus 3 out of both terms, which leaves 4x squared plus 5. When you look at our answer, that looks like the answers we got yesterday when we factored trinomials, a parenthesis times a parenthesis, a binomial times a binomial. Those are what our answers are going to look like. So again, what we do, we split it into 2 separate problems, the first half and the second half. Then, from the first half, we divide out the greatest common factor, 4x squared. From the second half, we divide out a 5. And then we have a common factor of x minus 3. We divide to the front. So we get x minus 3 times 4x squared plus 5. So let's go ahead and look at a couple special examples with factoring by grouping. For the most part, it's a pretty straightforward concept. So in the second example here, we have 8x cubed minus 12x squared minus 6x plus 9. I split my problem into 2 pairs. In the first half, I have 8x cubed minus 12x squared. The greatest common factor there is 4x squared. When I divide 4 out, I get 2. I had 3 x's. Divided 2 out, I have 1. I get 2x minus 3. And again, our goal is for these parentheses to match. We want the first parenthesis to match the second, just like it did back here, x minus 3, x minus 3. I need those parentheses to match. So from my second one, it would be natural to see 6x and 9. I can divide out a 3, which leaves negative 2x plus 3. However, my parentheses don't match. So therefore, I need to divide out something different. In this case, we have a sign issue, so I need to divide out a negative 3, which leaves positive 2x minus 3. So by dividing out a negative, I made sure those parentheses matched. So now I have a common factor of 2x minus 3 in both terms, which leaves 4x squared minus 3 as the other factor. All right, we're going to have one more example, and then it'll be time to move on. Our final example here represents a special situation, and that special situation is going to end up occurring quite a bit, and it's actually a simple answer. As I split our expression into two pairs, out of my first I can divide out 5x squared, and I'm left with x plus 4. When you look at the second group, x plus 4, that already matches this parenthesis. I already have it matched. But when we're factoring by grouping, I have to divide something out. So therefore, if it already looks the way I want, I can always divide out a 1. Because dividing out a 1 does not change the problem at all, but it creates my situation I need here. I need to have these two parentheses matching so I can divide out my common term x plus 4 times 5x squared plus 1. And again, if you would take the time, just like all the factoring that we've done, if I would take the time to FOIL this out, x times 5x squared is 5x cubed. 4 times 5x squared is 20x squared. X times 1 is 1x. 4 times 1 is 4. That's the exact same problem written in factored form. All right, good luck.